Hello, this is the third video of Beginning Artificial Intelligence, and we are going to look at some Keras. So to begin, we want to include TensorFlow and call it TF, and we want to import Keras from TensorFlow. And we're also going to want NumPy, sleep, plot, and that. And then once we have all this stuff, we can do everything we're about to do. Alright, so to begin, I call this little thing right here. What this does is it just tells me if I'm using my GPU and what's the device name. If I'm not using a GPU, it will return an empty string. And then this, I was just having a problems with like my memory growing on my GPU, so that's why I have this right here. And they actually don't have a version 2 part. That's why I have this compatible V1 thing. Alright, so now we get the data right here. So we can use Keras, and they actually have this whole dataset thing that you can just download a dataset if you call the function. So we're downloading the fashion dataset, and you can see that it has images of t-shirts, trousers, and all that stuff right there. And then right here, I take the shape of it. Of this data right here. So this is train data, the X, the input. This is the output for train, and this is the validation data, input and validation output. And so right here, I'm just outputting the initial training shape. Then over here, because I didn't want to use make the video take a long time while training, I changed the size to 10,000. So pretty much I just out of this, I think there's about 60,000 images or something in here. So what I pretty much do is I randomly choose 10,000 of them. And then after that, we have to take the images and we have to expand the dim, which pretty much makes it so that each image, so like if we make an image real quick, this is kind of what an image looks like. And it has this stuff in there. This is going to be like a really bad image. But pretty much if you have one there and one there, this is what this is doing. Before we do, Before we do that, it actually looks like this. And that doesn't work for the convolution layer, so that's why we do that. Alright, and then right here, there's other ways you can do TensorFlow with this, I think, but I just use NumPy, which pretty much what an identity does is it makes a one-hot encoding, which would look kind of like if we'll do something, actually. I'll show it real quick. So let's get command prompt real quick, and we can get Python, and we can import NumPy. Oh man, as that, and then we can just do identity. You put how many identities you want, which I'll just do 5, and I don't know how to spell. Alright, so pretty much it just does this. And you can also do MPI, I think will do it also, but I just do identity. Alright, so once we do that to everyone, which if you can see also here, if we were to make a thing called ty like this, and we could put a couple values in there like that, we can actually call mp, well, just to make it so I don't have to type as much, I'll do I, and we can put ty in there. And of course I made a value too high. Let's just change that to 3. Okay, so now you can see, so now what it does is it finds index 1 and it makes it like that, finds index or 2 and then 3, 4. Wait, yeah. So after we do that, we print out these shapes again just to see what it looks like, and then we do the initial validation shapes. We do the same thing, expand it, do the identity thing, and then print that out. And then we get into the Keras models, which this is actually the beginning of some machine learning right here. So this is the basic model. I just made it up. There's a bunch of different things you can change. You can see all these things here. These are all hyperparameters, and they can all be changed to things. So I just messed around and I just put 32 because that's a relatively small value that actually kind of would work. So that's why it's called basic. So I just did a small little value there. We can change this if we wanted to. So there's sigmoid. If we could do a sigmoid, they're all just different activation functions, which just do different stuff to the output of the dense layer. This one's the best, so I just use that. And then you can see this one has a different one. This one's softmax, and this is special because this is the output one. So when we're outputting stuff, especially what we're about to do, so if we look over here, we're trying to classify stuff. We're given an image and we want to say, hey, that's a t-shirt, hey, that's a shirt. So what a softmax does is it will give you the probability which one is which. So if you give it a t-shirt, it'll probably say like a t-shirt 0.9% and maybe like a shirt 0.1% or something like that. So then you just find the highest value and you know which one it is. Okay, and then right here we just make the model, so you give it the input right there and then you give it that output, which is the last one we do. And then we compile it, which pretty much just makes it so we can give it an optimizer, and then we give it the loss function, and we can also give it metrics. The optimizer can be changed a bunch, and if we actually look at the Keras website real quick, we can go look up. Well, I think I can just scroll down here. Well, I'll just look it up. So if we just look up optimizer real quick, we can click that, and now these are all the optimizers. So you can see there's this one right here and all these. Atom's pretty good, so that's why I use it. This is like the worst one, so definitely use RMS prop or Atom, and a couple others are pretty good too, I guess. And you can see on all these, if I find the Atom one right now, you have this thing called learning rate. So this is pretty much the only thing you really tweak with optimizers. I sometimes enable AMS grad, but really the only thing you really want to tweak is this. And the higher the value, the faster it learns, but it can give you bad results. So you want to keep it relatively low, which is the default right there is a pretty good value. Sometimes you need it lower, sometimes you can raise it a little bit. If something's not working, it's a little better to lower it, and if it's being really slow but is working, you can raise it up. All right, so that's enough with the optimizers. And actually, let's go back. We can look at the loss functions real quick. So there's a bunch of loss functions. The main one is this one, mean squared error. That's just MSE. You don't have to type that whole thing. And you can also, this one's sometimes useful, mean absolute error. You can just type MAE. And then I sometimes use this one too, but yeah, these are the like classifier ones. So right here, all the cross anthropy ones. So you can see like the one we're about to be using, I think, was this one right there. So you don't really have to mess with all these values, and these are actually the functions. These aren't the classes, I think, because you can just pass them in here. And then there's also metrics, which are pretty much the same thing as a loss function. And then I have this right here just because my GPU is doing some weird stuff, so I just put that there. All right, so now let's move on to a little more advanced model. And this model has another same dense layer right here, but this time we have this thing called batch norm. And batch norm is pretty much just like you just put it in and it makes everything better. Sometimes that's not the case, but if you just put it after a dense layer, it can be good. Some people prefer to put a dense layer, a batch norm, and then the activation function, but that's a little harder to write because you have to split up the activation function from the dense layer. So I just put it after, and there's not much evidence proving that it's worse, especially for convolution layers, which we'll get into eventually. Alright, so these values you can tweak. The defaults, these are I don't know if that's the default, but this is the default for the momentum. The higher the value, it's just I think it has like a weighted moving average, and so the higher the value, just the quicker it moves. Okay, and then I kind of explained that, so that's all good, I think. And then again, same stuff here. And I never explained this flatten thing, so actually all the flatten thing does is you give it an image, which is a shape right here, which is actually going to be probably 28, maybe 24, I don't remember exactly. And it's going to look like that. So when we flatten it, it just turns it into one dimension of 28 times 28 times 1. Okay, so now we're going to actually get to a convolution layer real quick. A convolution layer is mainly for images. So now you see we're not flattening it yet. We do flatten it for the dense layer over here, but we don't flatten it yet. And we have the filters, which is kind of like this number for the dents, but it's a little different. You can look up an image to kind of visualize it for yourself. And then the kernel size is how big the filter is going to be. And then the stride is how much we kind of jump. So again, you can look that up to visualize it more. It's a little harder to explain. But and then we also use activation right there. And then we flatten it and all the same old stuff. So the convolution layers are good though, because you have a little filter, which for this one would be a 5x5. You can do this if you want to make it more explicit, but I just do 5 because they're all the same. And it will have a 5x5 like weighted matrix, and it's just gonna have eight of those, which are the filters right there, and it's gonna have a little that stride right there, and it's just gonna go over every part of the image, and then it will return that value, that result, and then we flatten it, and then we do the same thing right here with the dense layer. So the reason why we stride it though is because it will actually cut this image. So from the 28 thing we just had over there, it's going to cut it in half, which would make it look like that. So that's kind of why you stride it. And then we'll see in the next example down here, which is the more advanced convolution layer. You can see how every time we stride it, we also double this. And that's pretty much because we would lose information if we don't, because we're cutting the image in half. But if we don't expand the filters, it's gonna make it have to compress, and we're not trying to compress. We're just trying to get the answer of classifying this. So you don't want to compress necessarily, especially for this case. And then you can see all the batch norms between each layer, and you don't want to put one on the last layer. That can mess it up, especially if it's softmax. It depends on what you're doing, but for a softmax, you definitely wouldn't want to put it like right here. All right, so that's all the models I made. There's thousands of different types of models you can make, but that's just the 4 little basic ones I wanted to make real quick, and then we can run it. So again, my computer is not going to be able to handle all this, especially filming, but if we run it real quick, it's not going to get the best result, but we can just see what it does. So this is just all this putting, oh, forgot to remove that. Alright, so all this stuff you see with the TensorFlow core stuff, that's just because it's putting all the stuff on my GPU. And then that's the summary, that's what the model looks like. And you can see this is what the close looks like. And so you can see right here which ones are correct predictions and not. And then now it's just going to try all the 4 models. So we're on the second model. This one should be a little better because it's more complicated. And then especially, we're not giving it many epochs. So the more you train it, pretty much the better it's going to be. If you train it too long, you may not be able to generalize. You might just get so used to the data, the training data, that you won't be able to, like, you'll do bad on the validation data, which if you scroll up right here, you'll see the validation loss. So it's not training on the validation stuff. It only trains on the training data, which is kind of how you can see if it's generalizing or if it's just learning the training set. Okay, so that's it. And I'll just explain all this stuff down here real quick. So pretty much I just put all the models in a list so I can use them as a function for each one. I get the name of these so I can just print them out to make sure I'm using it. When you call model summary, it will print out, as you kind of saw this whole thing right here, it'll tell you how many parameters and stuff you're using. And then you fit it. This is how you train it. So you put the X training data, the Y training data, and then for the validation data, if you have validation data, you would put it in a tuple and then right there. And then you have the batch size, which from my projects, I just try to put as high as I can, as high as my GPU will allow. And then you want to put pretty high epochs, but again, if you go way too many epochs, you might start not generalizing, and that can be a problem too. And then if you want to save weights, you can do this, and the load weights, I'm pretty sure if you were to just save them, you can just do load weights and the name right there. If you want to load the weights you save. So you definitely, if you're going to have it run for an hour, you definitely want to make sure you save the weights. And sometimes I even put it in like a try block or something, so that if something goes wrong, at least you saved the weights and you didn't just waste an hour. And then right here, I just do a safety thing just to make sure there's more than 10 elements or datas in the validation data set. And then I just predict the model. You can also type predict like this, but it's kind of shortcut just to do the model and then put in all this in here. And then what happens is we expand this. Oh yeah, this is different expansion than the expansion we did way up there. What this is doing is it's making it, if you have one image, the model won't take one image, so you have to put the image in like this, because normally you're training it like this, and so if you were to just give it image like that, it's going to complain. So you have to put it in another list. So by doing the expand dims with the outer right there, then it will do that. And then we cast it to a float because these are images and they're all 255 or 0 to 255, which is uint 8. So we could, like, the normal is this. That's what an image is normally. And then the output right here, the reason why we do that is because, again, we surrounded it like this, so the output is the same. Oh, you get the point. Okay, so then once we get that, we do the argmax, which the argmax pretty much it gets this prediction. So I'm going to simplify it, but you get like 0.8, 0.1, and let's just say 0.5 and 0.05, I mean. And then, so pretty much this could be like t-shirt, trousers, purse, and shirt. And what we do is we find the highest value, and this will give us the index, which is 0. So if we do argmax on that, we'll get 0. And then with the 0, we index label, which if we would to look up to the top, t-shirt. So if that's 0, we get t-shirt. And then same thing here. So this one's the truth value. This is the predicted value from here, from the model. And then we just print that out. And then using a plot, we just show the image. And we squeeze it too. The same thing, because we expanded all those values in the image so that the convolution layer could work. So we have to unsqueeze it. Or I mean, we have to squeeze it from the expansion we did earlier. And then I just pause that the image for 0.1 of a second, and then that's it. So that's pretty much an introduction to Keras. We may get into some TensorFlow stuff, but I'm planning on getting way more in depth into Keras because it's a little easier and we can do a lot more cooler things, especially some big projects. So that's pretty much it for this video, and see you guys in the next.